Hello, chemists. We have another sample problem here that's going to deal with the dilution equation. I brought some visual aids here to help people visualize what this would actually look like in a chemistry lab. This problem is super realistic for something that we would do, and in fact that we will be doing in the second semester. So I brought, as you may know, my favorite dye. This is crystal violet, and there's a liter of it sitting over here. I didn't bother to try to accurately make up my solution, but this is probably not an unreasonable number to have the concentration of that dye be 6 times 10 to the minus 3 molar, or 6 millimolar. Sometimes these big organic dyes are super potent, and it doesn't take very much for them to really drastically change the color of a solution. All right, so here's my start material. So this big guy right here. The student needs to create 100 milliliters of a smaller, lower concentration. So I picked 1E minus 5 molar solution for a lab. How many milliliters of stock solution should be added to the 100 milliliter volumetric flask before filling this flask back up? So here's what you would do. So we're about to do a calculation. We're going to find that it's a relatively small volume from this big guy that I need. And so I might use something like this pipette here. And I'll show you guys how to use these, but what you can do is you can dial in a certain volume that you want that I can draw out of my stock solution. And I would put that tiny volume into this volumetric flask here. And if I hold it over the table a little bit, you can see very gently an etched line there. Anything below that mark, to have it full below that mark means that you have precisely 100 milliliters in this particular volumetric flask here. So 100 milliliters. All right, so what we would do is we would pull a tiny amount of the stock solution using this guy. We would put it into the volumetric flask. It barely is going to cover the bottom. And then what we would do is we would fill to the mark with some fresh deionized water. All right, so let's do our calculation here. We would turn to the dilution equation. So M1V1 equals M2V2. And really what we're doing, and I've discussed this in a different video, if I use these units, liters and molarity is moles per liter, then I just say the moles before is equal to the moles after. So what I'm saying is I'm going to try to deliver a certain number of moles of my dye into this and to be contained in the 100 milliliters. And I need to figure out what volume I need to pull from the stock solution. That's going to be this guy, so that I can deliver that many moles. So here's the important part. While I have 1,000 milliliters of this particular stock solution, I'm not going to use that number in my calculation. This is going to become my variable. I'm saying how many or how much volume should I pull so that I get all of the moles of my dye that I want, and then I'm going to spread that out into 100 milliliters. So it's going to look like this. M1V1 is equal to M2V2. This guy right here is going to be my variable. So I have 6.0 E minus 3 molar to begin with. Don't know how much of that. I don't know what I did there. Forget that. Pretend that's an initial, and now it's a big one. All right. I'm targeting to, in the end, I want 1.0 E minus 5 molar, my lesser concentration, and 100 milliliters of that. Okay. So if we were doing sig figs, notice I have 2 here, I have 2 there, I have 3 here. 2 is going to be my limit. But I'm going to say V1 after I solve this out. Need my trusty calculator here. Okay, so I'm going to divide this number over. So I have 1 times 10 to the minus 5 times 100 divided by, open parentheses, this is going to be in a denominator, so depending on how you type it into your calculator, make sure that you type it in correctly. I'm going to open parentheses just to be safe and say 6 times 10 raised to the minus 3, close parentheses. This is going to be 0.166 repeated and so on, okay? However, with my significant figures, V1 is going to be 0.17 milliliters. Now again, what I would do is I would come over here, and these are not universal on these little scales, but I would come in and I would dial in that particular measure. You can see that number getting smaller there. I'm gonna save you some time and not watch me do it, but I would dial in, I would grab that much from here, squirt it into my smaller volumetric, and then fill to the mark. I don't know why I just lost the focus here, but all right, hopefully that helps.